Alright, hello, this is Z Mathematics, and today we are doing the method of differences. So let's just get straight into it. So method of differences is Corpio 2, the beginning of chapter 2, and it's again to do with like series, but it's for, I guess, when you don't have the Corpio 1 type, where if you've got like, you have to find the sum from like r equals 1 to n of r, or like r squared or r cubed, and you can use the formula of like n plus 1 over 2 and all that. You can't really use that over here. So if we just look at the first example over here, so we've got the sum from r equals 1 to n of 1 over r minus 1 over r plus 1. So we can't use any formulas like n plus 1 over 2. We can't do anything like that because there's no formula we know for like 1 over r or 1 over r plus 1. So what do we do here? Basically, we just kind of start writing out the sum. So when r equals 1, so that's right, so equals, right, so let's put r equals 1. We should know how a sum works by now, so first we just plug in r equals 1, so we'll get 1 over 1 minus 1 over 1 plus 1, which is a half. So we just change that to a 1, so 1 minus a half. When r equals 2, we'll get 1 over 2, and remember this is like positive half, so like we're adding it because it's a sum, minus 1 over r plus 1, which is 1 over 2 plus 1, which is a third. When r equals 3, we get positive 1 over 3 minus a quarter. R equals 4, we get positive a quarter minus a fifth. R equals 5, blah blah blah, so we'll just put dot dot dot. Now, because we're going up to n, it's not like defined, like n could be 10 or 100 or whatever, it's not defined, so let's just go for like r equals n minus 1. Well, when r is n minus 1, we'll just get positive 1 over n minus 1 minus 1, right, so because at this stage r is n minus 1, r plus 1 is going to be n minus 1 plus 1, which is this n, so minus 1 over n. When r equals n, we'll get positive 1 over n minus 1 over n plus 1. Right, now we have to find the expression for this sum. Well, if you notice here, this and this cancel, this and this cancel, this and this cancel, there'll be positive a fifth over here, so this and this will cancel. So you can see there's a lot of cancellations. So basically, like we just said, that will cancel, that will cancel, that will cancel, this will cancel over here. Now, over here, when r is like n minus 2, here we'll have minus 1 over n minus 1. So this and this will cancel over here, and we can see that this and this cancel over here. So our final sum, what we're left with, is 1 minus 1 over n plus 1. So we get 1 minus 1 over n plus 1. And if we just combine the fractions, this will be n plus 1 over n plus 1 minus 1 over n plus 1. And well, n plus 1 minus 1 is just n over n plus 1. So our sum of 1 over r minus 1 over r plus 1 is just n over n plus 1. Now this is called the method of differences. Differences, there's going to be like a minus, so we've got this 1 over r minus 1 over r plus 1, that's a difference. So method of differences, the differences over here, they just cancel out. So this is how you do it for basically everything. You just find the cancellations, and then find what terms are remaining, and then you just add those or subtract those terms, whatever it is, and there you go. But there's kind of like a, I guess, simpler way to do it. So if we have u subscript n, or like u of n, basically that just means a term in a sequence or series, like it's just a term. Kind of like, I guess, like the nth term. So if like a term in some sort of series is in this form, f of n minus f of n plus 1, then the sum of u of r is f of 1 minus f of n plus 1. Now, this is basically what we had over here. If u of n is equal to f of n minus f of n plus 1, then u of r is just going to be f of r minus f of r plus 1. So if we look here, this is in terms of r, so that would just mean that f of r was equal to 1 over r, and then f of r plus 1 is 1 over r plus 1. So f of r minus f of r plus 1 is literally this. So this satisfies this. So therefore, our answer would be f of 1 minus f of n plus 1. Well, if f of r is 1 over r, then f of 1 is 1 over 1, which is what we had over here, and f of n plus 1, well, now speaking in terms of n, f of n would be 1 over n, so f of n plus 1 would be 1 over n plus 1. And we're minusing that, which is what we had over here. So that's where we get this. So instead of doing like the whole method of differences process, if we recognise that, oh, this is actually in this form of f of r minus 1, we can just straight away say that, oh, that's just equal to f of 1 minus f of n plus 1. Straight away get to this step instead of doing all this. So if we recognise the form, then we can just get our answer straight away. Done. So we can do it over here. So we have the sum of 1 over 4r squared minus 1. So straight away you should be able to see 4r squared minus 1 is a difference of two squares. So we can rewrite this as the sum from r equals 1 to n of 1 over 2r plus 1 to r minus 1. Now, we have got a big fraction with two linear denominators, partial fractions. So we can say that 1 over 2r plus 1 to r minus 1 is equal to a over 2r plus 1 plus b over 2r minus 1. Multiply everything over by this denominator, so we get 1 is equal to a multiplied by 2r plus 1, and 2r plus 1 will cancel out, so we'll get 2r minus 1 plus b into 2r plus 1. Now to solve for a and b, we'll try eliminate each one. So 2r minus 1, if we were to make that 0, r would be positive a half. So when r is a half, we get 1 is equal to, this makes 0 then, so this whole thing would be 0, so what we get is b times 2 times a half, which is 1, plus 1. So what we get is 2b equals 1, b is a half. Now here r will be negative a half, so when r is negative a half, we get 1 is equal to minus 1, which is minus 2, a plus 0. So a is negative a half. So rewriting this, our a over 2r plus 1 is minus a half, so minus a half plus a half, and we'll just rewrite this. We can factor out a half, so what we get is, we'll do this one first because that's going to be a minus, so we're going to subtract it. So we'll get 1 over 2r minus 1 minus 1 over 2r plus 1. So just erase this. So what we now get is this sum over here. So we have got, because we've got half, we'll take the half out, so we get half the sum from r equals 1 to n of 1 over 2r minus 1 minus 1 over 2r plus 1. Now, what do we notice about this? If we were to let f of r equals 1 over 2r minus 1, f of r plus 1 is going to be 1 over 2r plus 1 minus 1, which is 1 over 2r plus 2 minus 1, which is plus 1, so 1 over 2r plus 1. So if 1 over 2r plus 1 is f of r plus 1, and we've got f of r, well, that fits this. So we can just say instantly, well, it's in this form, so this sum over here is just going to be f of 1 minus f of n plus 1. So what we get is a half, and like we just said, this sum is equal to f of 1 minus f of n plus 1, so f of 1, well, we just said f of r is 1 over 2r minus 1. So f of 1 is just going to be 1 over 2 minus 1, which is 1 over 1, which is 1. So we get 1. Right, now here we have f of n plus 1, so 1 over 2 n plus 1 minus 1, 1 over 2n plus 1. So because we're minusing it, we get minus . Now we'll just simplify this. So now let's just tidy up in here. So we'll get it as one fraction. So we get a half into, now 1 is 2n plus 1 over 2n plus 1. So we'll get a common denominator of 2n plus 1. So 2n plus 1, which is this one over here, minus 1. So minus 1. So we'll just get 2n. So what we get is 2n over 2n plus 1. Well, if we multiply it, this and this will cancel out. So we'll just get n over 2n plus 1. This is our answer for this sum. Now, what if we don't have it in this form of f of n minus f of n plus 1? If we, for example, have f of n minus f of n plus 2, then, by using the method of differences, we find that the sum of that is f of 1 plus f of 2 minus f of n plus 1 minus f of n plus 2. Now let's just show this with this sum over here real quick. So the sum of this, well, partial fractions again. So we can say that 2 over r plus 1, r plus 3 is equal to a over r plus 1 plus b over r plus 3. Now multiplying by that, we'll get 2 is equal to a r plus 3 plus b r plus 1. If we let r equals minus 3, we get 2 is equal to, this will be 0, so we'll just get b times minus 3 plus 1, which is minus 2b. So b is minus 1. If we let r equals minus 1, we get minus 1 plus 3, which is 2, so 2a equals 2, a is 1. So a is 1, so that we'll just get 1 over r plus 1 minus 1 over r plus 3. So this sum is 1 over r plus 1 minus 1 over r plus 3. Now, this is in this form. F of r is 1 over r plus 1, and f of r plus 2 is 1 over r plus 2 plus 1, which is 1 over r plus 3. So f of r minus f of r plus 2, or f of n minus f of, is equal to this. So it follows this form. So straight away, we'll just use this formula. We'll say, oh, it's just going to be f of 1. Well, f of 1 is 1 over 1 plus 1, which is 1 over 2, plus f of 2, which is 1 over 2 plus 1, which is 1 over 3, minus f of n plus 1, which is going to be 1 over n plus 1 plus 1, which is n plus 2, minus f of n plus 2, which is 1 over n plus 2 plus 1, which is n plus 3. Well, this is going to be 5/6 minus, now this is going to be 1 over n plus 2 plus 1 over n plus 3. So we'll combine this inside fraction, so we get 5/6 minus, now cross multiply, so that becomes the denominator, so we'll get n plus 3 plus n plus 2, which is 2n plus 5, all over n plus 2, n plus 3. We'll just leave that in factorized form, so n plus 2, n plus 3. Now we'll combine these fractions, so we'll get 5 lots of this minus 6 lots of this, so 5 n plus 2 times n plus 3 is n squared plus 5n plus 6. So actually that's just going to become 5n squared plus 25n plus 30. Minus this, so 6 times 2n plus 5, so minus 12n minus 30, all over 6 lots of n plus 2 times n plus 3. 30 and 30 cancel out. 25 minus 12 is 13, so we get 5n squared plus 13 all over 13n, all over 6 lots of n plus 2 times n plus 3. Guess we can factorize a little bit more, so we get n into 5n plus 13 all over 6n plus 2 n plus 3. And that's done. Now let's just quickly show this by the method of differences. So we've worked out that this will be the sum. So 5 to 6. So here we're going to have n plus 1 to n plus 2. So this n plus 1 and n plus 1 cancel out. So what we're left with is a half plus a third from over here, minus 1 over n plus 2 minus 1 over n plus 3. And this is exactly what we have over here. So we can do it both ways. We can use this formula to get it straight away, or use the method of differences to get that. So that's all for today, just explaining what the method of differences is. Next we'll have some exam questions. So yeah, hope this was helpful. Bye.